Good morning to all. In this video session, I am going to teach one of the important illustrative example called Towers of Hanoi. Okay. So this question was asked for 2 times in the university exams also. So listen carefully. Okay. So here, what is Towers of Hanoi? Anyone have the idea? Anyone played this game? Actually, it is a puzzle or it is a mathematical game. Anyone played in the childhood? Most often played in the childhood. Actually, the game consists of 3 rods, and n number of discs. For example, here I am taking 3 discs. Okay, 3 bars or rods are there, and 3 discs. Okay, the game works depend upon the 3 rules. Okay, the first rule is, at a time we have to take only one disc. The main aim of the game is from one pole to next pole we have to bring all the disc. Okay, in the ascending order form. You have to bring all the disc in the next pole. Okay, depend upon the 3 rule. The first rule is we have to take only one disc at a time. Only one disc at a time we can able to take. Okay. The second rule is always we have to take the topmost. Okay, if you are taking one disc means the disc whichever present at the top only we have to take. You can't take the disc which is present below the top disc or the down disc. Okay. The third rule is we cannot place the bigger disc on the top of the small disc. Okay. We cannot place the big disc at the top of the small disc. What are the 3 rules? The first rule is only one disc must be moved at a time. We can able to take only one disc and we can able to move at a time. The second thing is the topmost disc only can be moved. Okay, the topmost disc can be moved. The third rule is the smaller disc should be placed above the larger disc. That means the larger disc should not be placed at the top of the smaller disc. These are the 3 rules. Okay. By using the 3 rules, now I am going to solve a puzzle with the n number of discs, 3 number of discs. Okay. Listen. Consider these 3 are the poles. Okay. One, A, B, C. The 3 are the rods or poles, and these 3 things are the disc. This is the number 1 disc, this is number 2, this is number 3. This is number 3. 3 disc. This is the biggest disc, this is the second biggest, this is the third small disc. Okay. 3 rods and 3 discs. Now 3 conditions I will say. Okay, remember these 4 conditions, so that only you can able to do this problem correctly. Okay, the first one is if n equal to 1, that means if there is only one disc, you can directly move from A to C. Okay, if you have more than n means more than 1 means if the n value is more than 1 means, for example, here the n value is 3. So n is greater than 1. Okay. If it is like this means first move n minus 1 from A to B using C. A to B using C. Okay. The next rule is then move A to C. The fourth rule is move n minus 1 from B to C using A. These are the 3 things. These are the 4 things you have to remember. The first one is n equal to 1 means that is it have only one disk. If it is have only one disk, just take the disk from A to C directly. Suppose if the n value is greater than, the disk value is greater than 1. Here how many disks are there? 3 disks are there, right? Here 3 disks. So n greater than 1. If it is there means first n minus 1. What is n minus 1? N minus 1 is, n is here 3. 3 minus 1 means 2 disks. You have to move 2 disks from here to here. From the first pole to second pole. Okay, from the first pole to second pole, we have to move these 2 disks using this third disk. Using this third disk. All of you got it? Now we will see step one by one step. Okay, this is the first step. Initially 3 disks are there. In the first iteration, I am taking we have to take always the topmost, right? So I am taking the topmost disk from here to here using C. So I can put in the C. Okay. In the next iteration, I am taking the second disk. This is the third disk. I am taking the second disk and placing in the B. So now 1, 3, 2. Okay. What's the next step? I want to bring, see here, move n minus 1 A to B. I want to bring 2 disks at B, right? So again I am taking the third disk and placing in the first disk. So this is the condition we solved here. This is the condition we solved here. Move n minus 1. N value is 3. N minus 1 is 2. So you have to move 2 disks from A to B. Whether it is completed or not, it is completed, right? Using C. Till this we completed. Okay. Why I am telling these 4 steps means this is the algorithm, this is the pseudocode, this is the program for Towers of Hanoi. If you follow these steps, you can easily do it. That's what I am telling these 4 things. Okay. The next step is, once you completed, now you can bring this A, the first disk to C. So move A to C. See here, the disk which is present in the A is moved to C. So now it is 1, that is 2, 3. So the main disk moved to the last pole. All of you got it? Now what's the next step? Again move n minus 1. Here how many disks are there? 3 disks. So n minus 1 means 2 disks. 2 disks, I want to move from B to C, from the second pole to third pole. These 2 disks, I want to bring it here. As per the rule, move n minus 1, that is 2 disks. These 2 disks, I want to move from here to here. Okay, for that only I am doing. Now what's the next possibility? We can bring the third disk here, second is here, and first. Okay. Now what's the next step we can do? We can put the second disk over the first disk. Then we can put the small disk C here. So 1, 2, 3. Okay. So 4 rules are there and 4 ideas are there. Okay, to solve this problem. First, the game rule is we have to take only 1 disk at a time. The second game rule is we have to take always the topmost disk from the pole. Topmost disk means the third disk only we have to take first. The third game rule is we cannot place the bigger disk at the top of the small disk. This is the game rule. The ideas, there are 4 ideas to solve this puzzle. That 4 ideas are this. The first idea is, if only 1 disk, don't worry. Directly you can put from A to C, we can move it. If you have more than 1 disk, we can use these steps. First, we have to here actually 3 disks. For 3 disks, the idea is, first, move this 2 disk. Okay, move this 2 disk from A to B using C. With the help of the third pole, we have to bring the 2 disks. See here, I completed this. With the help of the third pole, I bring 2 disks in the center disk. center pole. Okay, all of you understood. Then what's the next step? Move A to C. Now bring the first disk, biggest disk from A to C here. From A to C I changed. What's the next step? So till this, the first step. Not first, second step. Okay. Till this, it is the second step. And this line is third step. 1, 2, 3, 4. Okay, this is the third step. And the fourth step is this. Again, move 2 disk. N minus 1 means 2 disk from B to C using A. So from B to C I moved using the A. So these two steps are recursion. The previous video session I will explain about the recursion clearly. So in the algorithm, this concept is also, this towers of concept also used or solved with the help of recursion concept. So for that only we are using these two steps. These two steps are the recursive function calls. While you are going to the algorithm, you can clearly understood these logics. Okay, now all of you understood the puzzle game and how you solve this puzzle. Okay, I hope you understand this. Next, we can see the algorithm, flow chart and pseudocode for the towers of Hanoi problem. Algorithm for the illustrative example, towers of Hanoi. Already we know the logic. I thought the logic of towers of Hanoi. With the logic, we are going to write the algorithms. Okay. So at first, we have to start the algorithm with start. Then define the function tower. Define the function tower. So what is this define a function? What is function? The previous video sessions, I taught you what is function. Set of instruction to do a particular task. And I taught you a recursion also. What is recursion? What is recursion? Function that call itself. Again and again we say recursion. Using the recursion concept only, we are going to solve this problem. Okay. So for recursion we need, what are the things we need? We need function, definition, function call, main function, then stopping condition. Okay. So for that only I am going to create a function or define a function. The function name is tower. What's the function name? Tower. Then what are the things present in the towers of Hanoi? The disks and the number of pillars or poles. Okay. So I want to get how many disks I am going to use from the user. For that only I am using a variable n. Read number of disks as n. So n is a variable which holds the value how many disks you are going to use. So from the user I am getting the n value. For example, it is 3. Okay. Then how many disks are there? How many disks are here? 3 disks we are using, right? So the first disk, initialize the pillars. Disk is 3. Then how many poles or pillars are there? 3, right? So initialize the pillars. A pillar is called as source. Okay, what's the source pillar name? A. And the aux pillar, the middle pillar name is B. And the last destination pillar name is C. I am assigning A equal to source. So A pillar is known as source. And the B pillar is known as aux. And the C is called as destination. Okay. So A is source, B is aux, and C is our destination. Then call the function. Okay, you are define the function, then you are calling the function. What's the use of function call? Till the function call executed, function definition should not be executed. Okay, you define a function, right? The function define want to work means first you have to call the function. Without calling the function, we can't able to use the function definition. Got it? So I am calling the function. While I am calling the function, I am passing the parameters. What are the parameters I am passing? N. What's the n value here? It is 3. What's the meaning of A? A is nothing but source. What is C? C is nothing but destination. What is B? B is nothing but aux. You are passing all the things to the function definition. Now this is the algorithm for function definition. So this is the main program. First I am defining a function, then I am calling the function. Here the function definition is there. Here the function definition is there. So what will happen? The value of n will be passed here. The value of a will be passed here. The value of c will be passed. And the value of b will be passed. So the values from the parameters are copied to the parameters which is present in the definition. Actually here the variables which is present in the function call, we say it is arguments. Defaultly arguments and parameters are same. But in Python, here we say arguments, here we say parameters. Okay. So the values from the arguments are copied to the parameters. From here the values are copied. Okay. Now what's the n value? Now the n value is 3. What's the meaning of A? It is source. What's the meaning of C? It's a destination. What's the meaning of B? It's an auxiliary, center pillar. Okay. Now I am checking three conditions. While I am explaining the logic, I am given 4 ideologies, right? So I am trying the first idea. See here. If n equal to 1, that means if only one disk is there, any problem is there for changing the disk? No. Directly from the first pillar, we can put into the third pillar. From source to destination, we can directly place it. That's what I am checking a condition. Check if n equal to 1, then move disk from A to C. That is source to destination. No problems. No need of any rules because only one disk. Suppose if you have more disks, how many disks you are passing? Here 3 disks. So otherwise, if it is more than 1, else part. Okay. Tower of, that is function name. Tower means function name. N minus 1. What is n minus 1? N value is 3. 3 minus 1 is 2. 2 box. From where to where we have to we have to shift. We have to shift from A to B. That is from the source to auxiliary. From the first pillar to second pillar with the help of C. Okay. So where to where we have to change it? We have to change A to B. Source to auxiliary. We have to change 2 bus. Okay. So once this is a recursive function call. This is the recursive function call. So how many times it will work? 2 times it will work. Okay. 2 boxes it want to swap. After completing this, the first box, the first pillar, after completing this, the first pillar or the first pole, only one disk will be there. That will be moved from A to C. Totally 3 disks are there. 3 boxes or 3 disks will be there. 2 boxes you are putting from source to destination A to B. So only 1 box will be remaining in the first pole. That you can directly move from A to C. That is source to destination. Got it? After completing this, now how many disks are present in the second pole, auxiliary pole? 2. How many disks are present in the destination? 1. How many poles are present in the first? Nothing. So now what we have to do means tower, it's another function called n minus 1. That is 3 minus 1, 2. 2 disks we have to take from auxiliary and put to destination C with the help of aux. By swapping from aux and all these things, you have to swap 2 disks from aux, second pillar to third pillar with the help of the source. Auxiliary to destination with the help of source. All of you got it? So at last you will get the pole like this. Like that you will get the disks in the last pole. Okay. So all of you understand this. So once again I am repeating, First you are defining the function, then read how many number of poles and how many number of disk, everything is over. From here function call. Once this function call executed, it will come to the function definition. At that time, the values from the arguments are copied to the parameters. Okay, now the n value is 3 and aux is, this a is source and this is destination and this is the auxiliary, middle. Okay, now if it is only one disk means directly we can take from the first pole to third pole. But here 3 disk, so it will come to the otherwise part. So here first 2 disk we have to take from the source to auxiliary, middle, second pillar with the help of destination. Then only one disk will be remaining in the first pole. Just move from the first to third one. Again from the, now in the middle pole 2 disks are there. That too you have to take from the middle and put to the destination using source. This is the ideology. Okay. So now we are going to see the pseudocode. What is pseudocode? With the help of keywords, we are writing the pseudocode. So first begin. For showing, instead of start, here we have to use begin. Then read n. What is n? N is nothing but number of disks. Okay. So it is here. Then initialize a equal to source and b equal to aux and c equal to destination. Just assigning the source to a and auxiliary middle to b and c to destination. Then it's a function call. So once the function call executed, it will execute the function definition. So the values from the function call is copied to the function definition. Okay. Now if n equal to 1, only one disk is there, we can directly move from a, that is source, to destination. Otherwise n minus 1, 2 disk we have to take from the source and put into the auxiliary. With the help of this, by using this C, we can able to adjust and put. After completing this, only one disk will be present in the where? The first pole, A pole. We can move to the C, destination, source to destination. Now, in the auxiliary, 2 disk will be there. That we have to move. So, n minus 1, 2. We have to move from auxiliary to destination with the help of this source. So, as you are using if, we have to put end if. Then, as you are using begin, we have to end with end. Okay. So you have to follow the indentation while writing the pseudocode. So once you are using if, else and all, you have to give the space, indentation space here. Okay. The same thing you have to represent it in the pictorial representation, that is flowchart. See, I am starting here with the oval symbol. Here also stop with the oval. And here read, what are the things we have to read? Read the number of disk. Then here initialization. For reading, parallelogram symbol. For assigning or initialization, rectangle symbol. Then this symbol. See here, rectangle symbol at the end, 2 lines. This symbol denotes the function. So as you are using function call, from here to here we are calling. Okay, function call. The program not ended here. Once the function call executed, it will go to the function definition. At that time, the values are copied from argument to parameters. Here you are checking a condition. If n equal to 1, if this condition is true, decision symbol. For function definition also same symbol for function. Okay. If the decision is true, what we have to do? Just print move from A to C. Suppose if it is false means, again it is a recursive function. So it's a function call, it will come here. So now the n value is 2. So I am checking the condition whether the n value is 1 or not. If it is 2 means, if it is 1 means it will print this, otherwise again it will work till it reaches 0. After executing this, this line will be executed. So nearly 3 times it will call the function. then it will move the disk from A to C. Okay. Now again call the function. Now from the auxiliary part you are moving to destination n minus 1 B to C, that is auxiliary to destination with the help of source. Okay. So again it's a function call, it will repeat again and again. Once it reaches 1, it will move A to C. Okay. From here the final answer will be written back here. That's what return is nothing but return statement is used to return the values to the call which it is located, where the function call is initiated. So it will return here and we can print it or we can use it. Okay. All of you understood? I hope you understand these towers of hanoi concepts. Thank you, students.